Hi, friends. So I just want to make sure that you have the opportunity to see how to add and subtract some of these polynomials before our next class. So I just want to take a moment here and look at how we would combine like terms. So first, we remember that those like terms are variables that have the same exponent, so the same letters raised to the same powers. So if I look at this first problem here, I notice that this x variable is x to the first power, and there's another term here that also has an x to the first power. These terms have an x and a y, so they're not like these first two. So this negative 2x is a like term with the positive 4x. The second pair here, this negative 3xy and positive 2yx, even though the order is different on the x and the y and the x, they have the same variables raised to the same power. And so these are also terms that are like with each other. Okay? So when I'm combining like terms, I'm simply combining the coefficients of the variables. So if I have negative 2x and positive 4x, I would combine those coefficients in the same way that I was adding or subtracting integers. So here I have negative 2 and positive 4, so combined that gives me positive 2, and then the variable remains like. The variable stays with the term, so that would be 2x. Over here I've got negative 3xy and positive 2yx, and so if I combine those coefficients, that will give me negative 1, and I'm going to write it as xy because we, generally speaking, write the variables in alphabetical order to save us from some of this confusion. In addition, I hope that you guys remember that the coefficient of 1 is often dropped from terms, so this would also be correct to write as 2x minus xy. Looking at the second example, we would similarly come through and identify terms that are like. So here I've got an x squared y term. So I'm going to look for other x squared y terms. So this is an x squared y. This one, be careful, this is an xy squared, so that's actually not the same term, so this one is like with this one. And then when I'm combining, I'm just going to combine those coefficients, so I have a negative 5x squared y and another negative 5x squared y, so combined that gives me negative 10x squared y. And here I have a positive 5 and a positive 5, so that gives me positive 10xy squared. Now, often you might see these like terms as separate expressions. So these terms are in what's called function notation, where we have a function or a rule, f of x, which is this expression here. So f of x is the same as this expression, 3x plus 5x minus 2. And here we have a second rule or function, which is equivalent to this expression, 4x squared minus 1. So if I think about that in terms of combining them by adding them, f of x plus g of x, I'm just going to replace f of x with this expression that it's equivalent to, and I'm going to replace g of x with this equivalent expression. So if I combine those, I would have 3x squared plus 5x minus 2. And I'm going to take that entire expression and I'm going to add it to 4x squared minus 1. So looking at these parentheses here, I used that to identify that these were the same, but there's nothing outside this parentheses that's being done to this first term, so those parentheses are really extraneous. I can just remove them. 3x squared plus 5x minus 2 plus, and then I guess you could think of there as being a 1 that you're distributing, but really there's nothing to change this over here, so I'm just going to remove those parentheses. Plus 4x squared minus 1. And now I'm going to come through and do the same thing with the like terms. I'm just going to identify terms that are the same. So I have 3x squared and positive 4x squared. I have 5x. I don't have another x for that second term. I have a negative 2 and a negative 1. And so combining those, 3x squared plus 4x squared is 7x squared. 5x plus, again, there's nothing to combine that with, so that just stays plus 5x. There's no other term. Negative 2 and negative 1 combine to be negative 3. I could also, if I wanted to, make this a little bit more creative, and I could say, hey, I want to take f of x and subtract g of x. So I want to take this first expression, or rule, and subtract the second rule. So I would do very similarly. I would do 3x squared plus 5x minus 2. But now I'm going to subtract 4x squared minus 1. I'm going to subtract the second rule. And the parentheses here are, for the first one, aren't really necessary because there's nothing out in front of it, but I just always start off with those parentheses to show that I'm dealing with this whole rule, this whole thing, this f of x, this whole thing is one thing. So those parentheses, just put it together as I substitute it in. So again, since there's nothing in front of it, it's just 3x squared plus 5x minus 2. But here I've got a negative sign that's actually in front of these parentheses, or I could think of it as a negative 1 that I'm distributing into this second set of parentheses. So here I'm going to be careful and take my time and make sure that I actually distribute that negative sign into the second set of terms, or the second expression. So that's going to give me negative 4x squared, and negative 1 times negative 1 is positive 1, or plus 1. So now as I come through and identify my like terms, I've got an x squared term, I've got a negative 4x squared, I've got a positive 5x with no other x term, and I've got a negative 2 and a positive 1. So now I've got 3x squared minus 4x squared, so that's negative x squared plus 5x minus 1, which is the solution for the difference of those two expressions. So again, adding and subtracting polynomials is really a case of just identifying and combining like terms. But remember, when subtracting those polynomials, to be careful to distribute that negative sign into this complete second term, because everything in that second expression is being subtracted from the first. I hope that helps. If you had any questions, and be happy to go over things in class as needed. Thanks so much.